Okay, we're in better shape now. Everybody can see PowerPoint slide says testosterone at the top.
Mm-hmm.
Cool. So we're right on track, right on schedule rather, for where we need to be in notes, which is really cool. We're going to finish up male physiology, which is pretty straightforward today, and start female anatomy today. So testosterone, we've already kind of talked about. Secondary sex characteristics, body hair, shoulders broader than the hips, thicker skin, larger muscles, larger larynx and a deeper voice, those kinds of things. Increased cellular metabolism. If it seems that in your 16 to 18-year-old lifetime that you can just eat whatever you want and essentially not gain much in the way of weight for a period of time, that is probably true. From about the age of 12, 13, give or take, when puberty kicks in, guys are getting a lot more testosterone in them. Their cellular metabolism is up, and so you are burning so many calories, a BMR, basal metabolic rate, which means how many calories does it take for you to lay on a couch and breathe that day. It's just to exist. How many calories are your cells burning? And for your average young guy who's close to 6 feet tall, that can be 2,500 calories a day, and that's just sitting sedentary, which is crazy. So there's going to be an increased metabolism and an increase in red blood cell production, and obviously stimulated sexual activity anytime after puberty when sperm cells are being produced, and testosterone is going to cause that. So here's kind of the flow chart for male physiology. And I think this is quite a good one. So basically, your secondary sex characteristics are directly proportional to the amount of testosterone in the blood. So a little more testosterone, a little more body hair, that kind of stuff. It is regulated by a negative feedback cycle. Too much testosterone, of course, could be a bad thing, and too little testosterone could, of course, be a bad thing. So it all starts in the hypothalamus, right up here. And in the hypothalamus, it will release GnRH, which is gonadotropin-releasing hormone. Gonadotropin-releasing hormone goes to the pituitary gland, which is nestled in the cella turcica of your brain, of your skull. So the pituitary gland has two lobes, an anterior lobe and a posterior lobe, and I don't really care that you memorize those necessarily, but the pituitary gland releases two very important hormones, FSH and LH, into your bloodstream. Now, once they're in your bloodstream, they're going to travel to the testes, where they're going to come into contact with interstitial cells. Those interstitial cells, here, I don't know if my underlining skills are quite up to par for this, but that's not bad. Once they get to the interstitial cells, they say, interstitial cells, it's time to release testosterone. The interstitial cells say, yes, finally, that's my only job, and I've been waiting 12 years to do this. And so the interstitial cells start to pump testosterone out. Testosterone, or the androgens, go into the bloodstream of this young man, and they're going to stimulate all of the secondary sex characteristics that we talked about. And so the testosterone levels in the blood go up, skin gets thicker, muscles get bigger, voice gets deeper, et cetera, et cetera. And the hypothalamus is sensing how many androgens are in this bloodstream. Okay, so once we sense in the hypothalamus that basically there's too much testosterone in the bloodstream, right? Or there's enough, we don't need any more, the hypothalamus can tell the pituitary gland, stop releasing these things by no longer releasing gonadotropin releasing hormone. So the hypothalamus says, no more GnRH. No more GnRH tells the anterior pituitary, shut them down. Anterior pituitary is no longer secreting FSH and LH, which tells the interstitial cells in the testes, shut them down. Testosterone levels decrease. Hypothalamus senses that, tells the pituitary gland, fire them back up. Pituitary gland, LH and FSH, interstitial cells get those, release testosterone, and the testosterone levels increase. So it's just like you're too hot, you sweat, you cool off. You cool off too much, you shiver, you warm up. That's homeostasis, right? It's not stable, it's a steady state. Okay, and so that's exactly the same thing. Too little testosterone, FSH and LH, go for testosterone. Too much testosterone, shut them down. And it's oscillating in these safe levels. And so that's essentially it for what I want you guys to know about male physiology. And it's a pretty cool system. It works great. So let's see. High blood testosterone inhibits hypothalamus. We already talked about that. Yep. Got it. Okay, cool. Low blood testosterone means we're releasing more GnRH, which means we're releasing more LH and FSH, and yeah, more testosterone. Got it. Okay, so those are the same things. So these slides are just telling you what I just told you. Okay, so that's it for the guys. Let's go for the girls. We're on schedule for this. So female reproductive system, we're gonna do the same thing: external anatomy, internal anatomy, physiology. Okay, so this is actually internal anatomy. We'll get to external in a little bit, but let's just talk about the functions. Much the same way that the crash course video said, it's really like they spend the entire video talking about testes and hormones and sperm cells and like 3 seconds talking about a penis, because most of the important stuff is going on in the gonads. Much the same way is that the case in the females. And so obviously the function of the female reproductive system is to create a mature, functioning haploid egg cell, which is not a particularly easy task, and then to transport that egg cell to the site of most likely fertilization, and then to get that egg fertilized and harbor it in a safe area, which is the endometrium. And we'll kind of talk about that step by step. So I don't anticipate you to memorize this diagram like right now, but just so you kind of have this at a passing glance, we'll kind of go into it in more detail. But essentially this guy right here is called an ovary. Okay, that guy's an ovary. And I guess I should probably say that girl. It seems inappropriate to say that guy, but whatever. So that girl's an ovary, and that's going to hold all the primary follicles that this lady was born with from the time she was a teeny tiny baby who like just came out of mom. She's got something like, I don't know, 4,000, 40,000 primary oocytes. More kids than your suburban will have room for, okay? That's how many oocytes. And so they have the ability to become eggs. And so that's regulated with this whole cascade of hormones, which is super cool, and we're going to talk about. But essentially, she's going to ovulate this little egg, okay? That little egg will then be swept by Fimbriae into what's, I learned it as fallopian tube, uterine tube is acceptable, oviduct is acceptable, pick a name. There's a lot of names for this. But essentially, the fallopian tube is a super narrow tube, and it's going to ensure the egg has the highest chance of being fertilized by a sperm. Like, you can't miss it, The fallopian tube's a small tube. The egg is a huge cell. Like, you can see a human egg without a microscope. It's a big cell. And so then the sperm is hopefully going to unite with the egg in the fallopian tube, and that's going to be called fertilization, if you didn't know the term fertilization. And so the egg would then travel down the fallopian tube. Let's see, we can draw this. Red is such a poor color. I apologize for that. And it's going to dock in what's called the endometrium. And so this big muscle right here, I have to change from red. We should change to black. I'm going to change pen color. I apologize. 1 second. Okay. This red muscle right here is a uterus. Okay. It has 3 layers. The middle layer is muscle. Okay, it's called the myometrium, and you remember the term myo from our muscle chapter, right? But anyways, it takes a lot of muscle to push a kid out of a person's body, okay? So a lot of the uterus is literally a big ball of muscle. Now, the outside of it is called perimetrium, which is, peri, about or around, the outside of the uterus. And then the inside gets maybe a disproportionately high amount of our attention, but it's super cool. And it's called the endometrium, which means within the uterus. So we have the layer inside, a big old muscle layer, and then essentially, a smooth connective tissue covering outer layer, like you've seen in other organs and tissues. And the endometrium is super tricky, but cool, because basically, and maybe I'm jumping ahead, but whatever, I'm just rolling with it here. Basically, every single month, a uterus gets ready to house a kid in 14 days. So the endometrium gets thicker and thicker and thicker and increasingly vascularized on days 0 to 14 in preparation for ovulation, which is when an ovary kicks out an egg. So by the time ovary kicks out an egg, The endometrium is very thick and has tons of blood vessels, so that should this egg be fertilized by a sperm cell, this little bitty zygote, embryo, diploid, gamete, pick a term, baby human, you can't miss. The baby human is going to hit a thick vascularized membrane and stick to that membrane. Then the baby human will pull some nutrition from that, grow out a teeny tiny placenta. That placenta will dock to mom, and the kiddo will start getting oxygen and nutrition from mom. Now, the reason that we're like, how did we get this far ahead, on female reproduction, is because the endometrium from day 0 to 14 will get thicker and thicker and thicker and thicker in anticipation for catching this embryo. If the embryo check that, back up, sorry. If the egg is not fertilized, okay, the egg is not fertilized, the egg passes through. These guys right here and right here are going to secrete hormones that say, hold on, lady, don't you dare have a period yet, because there might be a baby on the way. You need to wait. And it's going to give this inner lining of the uterus a few days for an embryo to implant. Now, let's say the embryo is not fertilized, right? It's just an egg, okay? The egg travels through. It doesn't dock. It doesn't get stuck anywhere. The egg passes through. Then the uterus, after a period of a few more days, will actually shed that entire inner lining of that endometrium. Clean slate, wipe it all out. That's called a period or menses. It's a period of bleeding where the endometrium is coming out of this woman. So the endometrium is sloughed off, comes out over a period of days, has a clean slate. That starts day 0. The whole process repeats itself. Day 0 to 14, thicker, 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 more blood, more blood, more blood. Day 13, 14, kicks out an egg and is ready to catch this embryo. Every single month it does this. This is why girls are so much more complicated than boys. Boys are like, I've got 270 million sperm. I don't know how good they are. It doesn't matter. There's 270 million. And girls are like, I've got one egg, and the conditions to catch this egg are going to be perfect. And so it's like a whole different animal, okay? I shouldn't say it. I use that expression all the time. It's a whole different situation. But anyways, so holy moly, how do we do a whole reproductive cycle with this diagram? I don't know. I can't, I don't know. Anyways, so it's suspended by ligaments, a round ligament and a broad ligament. If you don't know round ligament and broad ligament, I don't know if it's going to change your life necessarily. A round ligament is round and narrow, and a broad ligament is wide, flat like a sheet. So, I don't know if that's going to actually change your life, but there you have it. Let's see. Myometrium we've talked about. Perimetrium we've talked about. This right here is a cervix, which is the opening to the uterus. This has its own complicated processes of changes it goes through as well, which is pretty cool. But basically, there's the hollow muscular tube. That's called the vagina. The vagina leads to the outside world. Between the vagina and the uterus is a cervix. It's a very, very, very teeny tiny hole. For those of you guys who have had, how should we say this? Family members or aunts or uncles who are like oversharers during the delivery process, you might have heard terms like dilated. Like, oh my gosh, this baby's coming soon. She's 8 centimeters dilated. Or just got a text message, she's 4 centimeters dilated. Maybe you haven't heard these terms, but essentially, oh, sorry. What's that?
I don't know what it means though.
You have, but you don't know what it means. Hooray! Then prepare for your $4 worth of learning, sir, because here's what it means. This teeny, teeny, tiny cervical orifice has a pretty cool job. It's a little weird, but it's cool, right? It basically forms a mucus plug so that whatever bacteria or germs could get into the vagina because it's exposed to the outside world can't get into the uterus because the uterus needs to be a pretty sterile, pretty clean environment for that kiddo to land. Now, after kiddo is docked in endometrium, growing, and it's time to actually give birth, that itty bitty, teeny tiny cervical orifice will be stretched larger and larger and larger and larger. And that itty bitty, teeny tiny cervical orifice will eventually stretch wide enough to allow the passage of the head of a newborn baby, which is quite the trip. But That's the cervix, and that's what it does. It's cool because it forms like a mucus plug, right? That has to like leave at certain times to allow, the baby to leave and sperm to get inside, and like it's pretty closely regulated, which I think is fascinating. Let's see. What else do we need for this diagram? I think we pretty much got it. Fimbriae we'll talk about later, and fundibulum we'll talk about later. It's all highly vascularized. No duh, there's a great blood supply. That's not surprising. Cool. I think we got it. All right. So, any questions so far? You guys ready to keep going? Go once, go twice. Cool. Okay, no questions. You guys, you know how all this, the birds and the bees more so than most people at this point, I suppose. At any rate, transport the egg to the site of fertilization. No duh. There's only a couple of places in your body that have cilia that go like this, and that's your trachea. You breathe in dust, and the trachea has cilia that move the dust particles up so you can cough them out. And the other places, girls only, not for guys, is in the fallopian tubes. If you think about a concert, if you will, and somebody takes a very, very large beach ball and throws it into the crowd at a concert, and everybody uses their hands to kind of pass the beach ball along, and the beach ball slowly makes its way around the stadium of the concert, that's a pretty good picture of what it looks like for cilia to move an egg down a fallopian tube. Once the egg is out of the ovary, right here, okay, he is caught up in these fimbriae. The fimbriae kind of sweep the egg like this into the uterine tube because we don't want the egg getting lost, okay? You have to go where you're supposed to go. Into the fallopian tube, the egg goes. And the egg kind of bounces along, and the cilia do their little wave-like contractions, and the egg just bounces down the uterine tube, fallopian tube, oviduct, pick term. And that's the job of the cilia in the fallopian tube, and they do a great job. So we have to get the egg to the best place to fertilize the egg. If the egg were in the uterus, that would be like trying to find a needle in a haystack for the sperm cells, okay? A uterus is massive compared to a sperm cell, but a fallopian tube is a pretty narrow channel. It's a really good place for fertilization to occur. It's all very closely regulated because the fallopian tube is a terrible place for an embryo to implant. You want the embryo to implant in the endometrium of the uterus, but be fertilized in the oviduct. Juliana.
So what happens in the case of an ectopic pregnancy where like the embryo actually implants in the fallopian tube or not in the uterus?
It's like the saddest thing ever. Yeah, I mean, bear in mind I'm not a doctor, take it with a grain of salt, but best case scenario, embryo's gonna die. Worst case scenario, embryo and mom are gonna die. It stinks and it's sad. And I hope that some super smart OB finds a way to do a surgery where they like get in there and gently pluck embryo from fallopian tube and put it in the uterus, because it makes me very sad. But yes, an ectopic pregnancy or a tubal pregnancy, for those of you guys who haven't heard the term, is when egg is fertilized in the fallopian tube. For whatever reason, it doesn't make it to the uterus, but it gets enough of a blood supply for that kiddo to start growing a placenta in the fallopian tube and trying to grow. And that's very, very sad. Painful for the mother, fatal for the mother if the embryo is not removed. That's a very sad situation, because you've got a kid trying to grow in a tube that's about that big, and they can't, and mom can't, the kid can't, and so it stinks. But that's that's what happens with an ectopic pregnancy. Great question, Julianne. So it's very I don't know how to say it, finely tuned. It's a finely tuned system, to say the least. That's a really good question. Let's see. Next point, provide embryo environment to develop. We've already talked about that. Once the egg is fertilized, it's an embryo, diploid, zygote, whatever you want to call it, little baby, little kiddo. It needs obviously oxygen and nutrition to grow, and that endometrium will, if mom is pregnant, that endometrium will not be shed. She will maintain that endometrium for the placenta to dock for 40 weeks. 38 weeks is terms. Average Joe says 9 months. Twins is shorter. There's a lot of variation there, but essentially that's what you're talking about for the job of the endometrium after conception, fertilization, pregnancy, pick a term. And then obviously moving the offspring to the outside. The uterus, of course, has the very difficult job of having muscular contractions that make the uterus smaller because it is a circle. That's not entirely true. Whatever, close enough. It's not really a circle. To push that kid and birth that kid out into the world. And that's an important job of that uterus as well. And that has its own host of really cool, systems and that kind of stuff, but we don't have all year. We just have a week and a few days. And then obviously to produce female sex hormones. In this case, this is actually really cool. It's a lot like the guys in that, let's see, how should we say this? Hypothalamus to pituitary, pituitary to LH and FSH, LH and FSH to gonads is the same. Okay. So that's cool. Like the chart that we just did with the guys, if you just take testes and write ovaries and you take testosterone and write estrogen, that is very, very, very comparable. So that's nice. But that's where the comparisons end because it's so much more complicated. But, whatever. We'll get there. Okay. 4 minutes. Darn it. Okay. Our time is flying when we have 4 minutes. That's okay. External reproductive anatomy can probably be done in 4 minutes. I don't know. We'll get close. We'll see. Anyways, here's external reproductive anatomy for females. It's pretty straightforward. You have a couple of terms. Mons pubis is a pad of fat on top of the pubic bone. You guys already know the pubic bone and the pubis symphysis. So this is anterior, of course. This is posterior to the back. You learn the word perineum way earlier in the year. And so that's perineum. You basically have two sets of labia. You have the major labia and the minor labia. So this right here is labium majus. Labia majora is plural, which means the major lips. And that's pretty much going to house almost everything else so that it's basically creating that barrier between the vagina and the cervical orifice and the outside world. The opening to the space inside is called the vestibule. That's going to be between the urethral orifice and the vagina. The urethral orifice is right here. This would be where urine is coming out. And if you decide to become a nurse and you have to insert catheters later, that's the target. That's what you're looking for. And then obviously inside of labia majora, which is plural, is labia minora, which is the minor lips. Okay. Obviously anus is down there too. We did that in the digestive system, so that's not a big surprise probably. And the vaginal orifice is the opening to the muscular tube, which is the vagina. The only other term, which because it's not in this diagram, I guess that's why. So let's see. The other thing you should know about this is there is a very thin skin-like membrane that covers essentially this whole orifice right here to the vagina called the hymen. And that's not on this diagram and not on our points. No, that's okay. Anyways, the hymen is Hymen, and it's basically just another barrier against bacteria and fungi, separating those from the cervix and the vagina. The hymen at some point is going to be torn, whether that be through sexual reproduction or using a tampon or physical activity, like, whatever would stretch, that area. Pick something, running, hurdles, horseback riding, whatever, something is going to tear that thing at some point. And so that's a hymen. If you ever heard the term hymen, now you know. And that's pretty much it, really, that's about it. Oh, nope, that's not true. We skipped one. Sorry about that. Right at the anterior part, there is a very small structure called a clitoris. Okay. It is a very, let's see, how should I say this? It's a highly concentrated nerve ending point analogous to the glans penis, essentially. And that's what that is. So that is it. I think we got them all. Okay, cool. So let's see. Labia majora, protect other external organs. Mons pubis is basically a pad of fat and skin over top of the pubic symphysis. Nothing too new there. Labia minora would be medial to labia majora, which are minor folds. And let's see, they cover the clitoris anteriorly is what those guys are. Oh, shoot. I haven't told you the word vulva yet either. Sorry. So let's see. If you combine labia minora and labia majora, everything externally would be the vulva. It's like, how should we say that? I'm trying to think of a good analogy. So you know how, let's say we just said bulb, root, prepuce, and glands all together could be called penis. Labia majora, labia minora, clitoris, all together would be called vulva. That's probably the best way I can explain that. And I think it is, all right, it's 9:30.